We know that anything that has mass and takes up space is matter. So we're going to have to figure out how we determine how much space something takes up and how much mass something has, or how much matter is in it. So mass is the amount of matter or particles in an object. We measure it with a balance, so that's the tool we use. We have both analog or old school balances that have pans on them. We also have new digital balances. And we use the units of grams or kilograms. We don't use the units of pounds. Pounds measure weight, and mass is not weight. Weight depends on gravity. Mass does not. Mass is the amount of matter in the object. Doesn't matter where we go in the universe, the amount of matter is going to be the same. But because the gravitational fields are different, its weight will differ. Volume is the amount of space an object takes up. It's usually measured with a ruler by taking length times width times height. So if you have a nice regular prism-shaped object and you can measure all those things easily, it's pretty easy to get the length, the width, and the height, multiply those together. Or if we have something that's got a funny shape, we'll use a graduated cylinder. Graduated just means it's got markings on it. It's a cylinder because it's cylindrical in shape. So we can use that and the water displacement method to find volume. Now, it's got units of cubic centimeters or milliliters. Cubic centimeters because if you take length in centimeters times width in centimeters times height in centimeters, you have centimeters times centimeters times centimeters, which is a cubic centimeter. Milliliter is a cubic centimeter. So 1 milliliter is the same volume of 1 cubic centimeter. So 1 milliliter equals 1 cubic centimeter. They both describe the same amount of space. Now, if we have this thing, this little dinosaur-shaped thing, I can't very well multiply its length times its width times its height because I can't measure if any of those it's an irregular shape. So that's where the graduated cylinder comes in with the water displacement method. So let's take a look at that. Over here we have a graduated cylinder with some water in it. And this curved shape right here in the water, that's because water likes to stick to the sides of the glass, and so it kind of curls up the sides. We measure to the bottom of that curve. That curve is called a meniscus. And so this is 2, 4, 6, 8, 10, right? If these are divisions of 2, these graduations go by 0.2. So I have 4.2, 4.4, 4.6, 4.8. So I had an initial volume, or a starting volume, I'm going to say V1, of 4.8 milliliters. And then we drop in our object. Here's our little dinosaur dropped in, and the water level went up to 5.246. So I had a second volume, or V2, of 5.6 milliliters. Now what I'm interested in is the difference, or the change in volume. That's a Greek letter. It looks like a triangle. It's a delta, and it means change in. And so if I want to find the change in something, I take where it's at and I subtract where it started. So I take 5.6 minus 4.8, and I get a change in volume of 0.8 milliliters. So I know that that dinosaur has a volume of 0.8 milliliters because it moved that much water out of the way. It moved an amount of water out of its way equal to its own volume. So that's where the water displacement method works. Now, I can compare the amount of matter in something to the amount of volume it takes up, and when we do that, we get a measure called density. So it's telling me how much matter is in a certain amount of space. And this is a pretty characteristic measure. Lots of different matters have their own different densities. If you ever picked up a piece of aluminum, you know a chunk of aluminum feels pretty light for its size, but a chunk of steel feels pretty heavy for its size. And that's because steel has more particles packed into it in the same amount of space. So high density, a lot of matter in a small amount of space. Aluminum, on the other hand, not as much matter in that same amount of space, or even a larger amount of space. So when you pick it up, it does feel a little bit lighter. So not much matter in a large amount of space. Now the equation for calculating density is mass divided by volume. You'll see me write that as D equals M over V. And from that, it follows that its units have to be grams, right? That's what we measure mass in, per milliliter. That's what we measure volume in, or grams per cubic centimeter. Those are the same unit. They both describe amount of matter per amount of space. Now, remember, 1 cubic centimeter is the same thing as 1 milliliter. So let's take a look at what these two things mean. Water has a density of 1 gram per cubic centimeter. So if we had that, if we had 1 cubic centimeter of it, it'd have a mass of 1 gram. If we had 10 cubic centimeters of it, it'd have a mass of 10 grams. Gold, on the other hand, has a density of 19.3 grams per cubic centimeter. So if I had equal size samples, if I had a 1 cubic size sample of each, 1 cubic centimeter size sample of each, this thing, if it's water and it has a density of 1 gram per cubic centimeter, has a mass of 1 gram. That amount of volume has a mass of 1 gram. If I have a chunk of gold that is exactly the same size, and I was to find its mass, it would have a mass of 19.3 grams. It's got 19.3 times as much matter crammed into it. So all those particles are much closer together and therefore give it a whole bunch more mass in that same amount of space. Now, let's actually run through an example of calculating density. An object has a mass of 12 grams and a volume of 4 milliliters. Calculate its density. Whenever we do mathematics in here, there are a few things that you always have to do. You have to list your variables, and by variables I mean the information you're given. So if you don't want to call it a variable, if instead you want to say given information, that's fine. So given. These are your known pieces of information, and one of the givens is mass, 12 grams, and the next given is volume, 4 milliliters. V equals 4 mils. Now, calculate its density. So what I'm given is that. What I want is density, D. That's my question mark. So I know all my information and I know what I want. Then I have the relationship. Okay. Well, what's the relationship between mass, volume, and density? Well, density equals mass divided by volume. So this would be 12 divided by 4, which equals 3. And pay attention to your units. This mass was given in grams. This volume was given in milliliters. So this is grams per milliliter. Not too tricky. Let's take a look at one more example. A rectangular prism measures 12 centimeters by 4 centimeters by 7 centimeters and has a mass of 500 grams. Determine its density. Okay, this one is a little bit more complicated. Look at your given information. You're given a length and a length and a length. So it's a rectangular prism. That's a length, width, and a height. So I have a length of 4 centimeters, and I have a height of 7 centimeters, and I have a width of 12 centimeters, and it doesn't really matter which one you label what. Either of them could be length, height, or width. And we're also given a mass of 500 grams. So this is my given information. Now what I want is density. And in order to get density, I need mass divided by volume. But I don't have a volume. I have a length, width, and a height. So now I also want volume. And that means I need another relationship, but I have one. Volume equals length times width times height. So because this is a two-step process, I need volume to get density. I got to start with volume. So 4 times 7 times 12. And 28, 4 times 7 is 28, times 12 is 280 and 56, so 336 cubic centimeters, and that's cubic centimeters because we took centimeters times centimeters times centimeters. So mass divided by volume, 500 divided by 336 is going to give me a number a little bit more than 1, maybe 1.3ish, somewhere in there, grams per cubic centimeter. Feel free to use a calculator when you're doing this math.